In this video, we'll look at different types of triangle congruence. In the last lesson, we learned that two triangles are congruent by showing that all 6 pairs of the corresponding parts, so all the angles and all the sides were congruent. But it is possible to prove triangles that are congruent using fewer pairs. The first one is side, 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 or SSS congruence. So if we have three sides of one triangle, so we have 1 is equal to this one, 2 is equal to this one, 3 is equal to this one. 3 sides are congruent from the first triangle to the second triangle. Then we can say that the triangles are congruent. So triangle ABC equals triangle DEF because 3 sides are all congruent. The angle formed between 2 adjacent sides of a polygon is called an included angle. So adjacent sides would be like this side, and the angle formed between them two would be this angle. So any two triangles formed using the same side lengths and included angle measure will be congruent. And this proves the side angle side congruence. That tells us if 2 sides in an included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the triangles are congruent or equal to each other. An included side is kind of like an included angle, but now we're talking about a side. It's the side located between 2 consecutive angles of a polygon. So here would be 2 consecutive angles. So this angle, that's right next to the other angle. This angle next to this angle, and this side in the middle is going to be the included side. So if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So we can see this angle is equal to this angle is equal to this angle, and these 2 sides are equal to each other. So we can say by angle side angle, or ASA, that those 2 triangles are congruent. The congruence of 2 angles and a non-included side are also sufficient. So congruence of 2 angles and non-included side, we can also prove that 2 triangles are congruent. This congruence relationship is a theorem because it can be proved using the third angles theorem. So angle side congruent, so we have one angle equal to this angle, another angle equal to an angle on the other triangle, and then a non-included side that are equal to each other. So if 2 angles and the non-included side of one triangle are congruent to the corresponding 2 angles and side of a second triangle, then the 2 triangles are congruent. So let's summarize what we've learned so far. We've looked at the SSS, or side, 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 where all 3 sides are equal to each other. We've looked at the side angle side, or SAS, where we can see these 3. The side, the angle, and the side are equal to each other. We've looked at angle side angle, where we have an angle, a side, then an angle, equal to another angle, side, angle. And then we have AAS, angle, angle, side, where we see an angle, angle, and the non-included side equal to an angle, angle, and non-included side. And anytime we see those, we can say that the 2 triangles are congruent to each other. We can also look at right triangles and use the same things that we've already learned. So we can use leg-leg congruence, which is abbreviated LL. So leg-leg congruence is kind of like side, angle, side, side, angle, side. So if the legs of one right triangle are congruent to the corresponding legs, then the triangles are congruent. The next is hypotenuse angle congruence, abbreviated HA. So it says that if the hypotenuse So the hypotenuses are equal, and an acute angle of the right triangle. So one of these other angles is equal. We also always know that the right angle is going to be equal. Then the two triangles are going to be congruent. So this one is similar to angle side. Next we have leg angle congruence, which says that if one leg and an acute angle of one right triangle are congruent to the corresponding leg and acute angle of the other right triangle, then the triangles are congruent. So we have one leg that are equal to each other, and the acute angle of another right triangle are equal to each other, then we can say that those triangles are congruent. This one's similar to angle side angle. The last one is one we can only use with a right triangle, and it's hypotenuse leg congruence, abbreviated HL. It says that if the hypotenuse and one leg of the right triangle are congruent, so hypotenuse and one leg are congruent to the corresponding hypotenuse and leg of another triangle, then those two triangles are congruent. Let's take a look at some examples. So our first triangle, all we're given is a side equal to a side and an angle equal to an angle. So we don't have a side angle or angle side theorem that we can use. So these ones, let's say, are not necessarily congruent. The next one, we have side equal to side, another side equal to that side, and the third side equal to the third side. So we have side, side, side. So we could say these are congruent, and A, B, C. So let's make sure we do this in the right order. A, B, C. So the first one goes from A to B, has 2 hash marks. So we're going to say, let's see, D to F also goes through the length of 2 hash marks, starting at D, which has 1 hash mark between it and E. So let's say D, so ABC is going to be congruent to D, F, E. And B goes to C, D, F, E. And we can say this is by our SSS, or side, side, side theorem. Lastly, we have an angle, a side, and an angle. So angle, side, angle, angle, side, angle. So we can say these are congruent, and U, V, W, so we're starting at the angle with the 2 little marks for the arches there, so X, and then V is this spot here that isn't marked, so X, Z, this is the corresponding part of the other triangle, X, Z, Y. And Y matches W. They both have 1 little arc. So it's congruent to XZY based on angle, side, angle theorem.